Hello everyone. In this video, I will demonstrate how to conduct Factorial ANOVA using SPSS. As you may know that ANOVA is the statistical technique that you use to evaluate the significance of the mean differences on the dependent variable across many labels of one independent variable. That is simple ANOVA. But as you may know that in life, it is rarely the case that only one independent variable affects the dependent variable. Often you have two or more independent variables that are jointly interacting and affecting the dependent variable. And that's where factorial ANOVA comes into the picture. So in this particular case, we'll perform two-factor independent measure design ANOVA using SPSS. Now, the example I'm considering for this video is, let's say this one. Employees may be interested in determining if the income, and that's a variable name, R income 91, is different from those with differing degrees of independent variable, and whether the differences are the same for individuals who are very satisfied or not very satisfied with their job. So as you see that we have one dependent variable, we want to see the mean differences of income across employees with different degrees and uh, job satisfaction levels. So our dependent variable is R income 91, which is quantitative or interval scale variable. And we have two independent variables here. One is the degree, which has 5 labels here. And we have job satisfaction, which is sat job 2 variable name, and it has 2 labels, satisfied and not very satisfied. So first thing we need to deal with while conducting factorial ANOVA is to deal with the missing values and outlier. So this particular video will focus on how to deal with the missing values and outliers while performing factorial ANOVA. And these are the assumptions of factorial ANOVA. We're going to discuss that when we get there. I'm using this material from this book here. Very good book. If you get a chance, please go through this book. It's very informative. So with that detail here, let's see the data set and start conducting what we call uh, missing value and outlier analysis here. So I'll go to the SPSS. Now this is the data I have called career-d, and what we are interested here is the mean differences of income on different levels of degree and different levels of job satisfaction. So we have two independent variables. They have labels in them. They are categorical, and our income is ratio scale or interval scale or metric variable. So dependent variable in any kind of ANOVA or MONOVA will always be interval scale, and independent variables will always be categorical. So let's see one by one. Let's deal with the missing values in R income 91. So I will go to the variable view here, and let's see R income 91. Now, if you see the values here, R income is basically not a metric or quantitative variable. In fact, it's ordinal, but it has so many categories that we are treating it as interval scale, and that's done very often, because even the Likert scale, when you conduct the survey, is often 5-point Likert scale, which is basically ordinal in nature, but we treat that as metric or continuous or quantitative variable while performing the statistical analysis. So here we have R income 91. It has many different labels in them. So many different labels. We're going to treat that as interval scale. So you see that it's being treated as interval scale. If you go down here, you'll see category 22 is refused. People refuse to mention their income labels, and 98, 99 are sort of not applicable. So while performing the analysis, this could be misinterpreted as different income labels, while they are not income labels. They are just not the categories. So for this analysis, we're going to treat them as missing values. So let's go ahead and take care of this issue here. So I'll go to the data view, but before that, missing values, if you see here carefully, they already treating some of those categories as missing values, 0, 98, and 99. But this is not a 0, this is a missing value. So specifically 98 and 99, these are being there as treated as a missing value. So let's see what we have in the data actually. So if you go to the data view here, our income 91, I'm gonna sort this descending. Okay, so once I'm done with this one, you see we have the highest category of 98 and then 22. So we know that 22 is like refused, people did not mention their income, and 98, 99 were not applicable. So we don't have 99 here, but we do have 98 and 22, and we need to treat these as some missing values because they are not the actual labels, and that could be misinterpreted while conducting the statistical analysis. And if you sort this descending, then you will, I'm sorry, it should be ascending. So you have the minimum category label of 0. So 0 is being there as a category here. So that should be okay here. So 0 is also not a category, but you know, we'll take care of that, you know, when we are performing the outlier. So right now I want to treat any value that is greater than equal to 22 as missing values. So we're gonna go ahead and do the transform here. Transform record into different variables. Do our income here, and we're gonna name this variable as our income 2, and we're gonna do the old and new values here. Let's say the highest value through highest, so 22 through highest. Treat that as a missing. I have already this thing. I'm gonna remove all these things here. So 22 through highest, treat them as missing. Else copy all other values. So copy all other values as is. So that's gonna, what's gonna do is gonna take my R income 91, and wherever you have 22 or highest is gonna be treated as missing values. Else the data will be copied as is. I'm gonna continue this one. Say okay here. So if you go to the data set, it's created 92 here. Okay, so if I sort it ascending, see all these things are being now treated as missing. So here 22, but all this, if you sort this one by descending, you'll see all this 22 up to 90, 22 are treated as missing values here, or income 2. Okay, and then 21 is a valid one. So this is how, you know, basically you have to see the missing values here and take the appropriate action. So let's see how many missing values are there in our R income variable. So I will go to the analysis, descriptive statistics, and explore here. I will go to my R income 2 variable. I just want to see the missing values. So I'm not going to do any plot. I'm not going to do any box plot. I'll just go with the histogram because I have to choose one here. Otherwise, it won't perform anything here. Options, when you're doing explore, you pay attention to this option here, exclude cases list-wise. So it's going to ignore any case that have missing values. It's just going to do complete case analysis. That's the default here. So say okay here. And you'll see that for our R income 2, we have 710 valid records and 37 are missing. And that's only 5%. Okay. So only 5% are missing. If the data missing is that low, we usually just ignore it and not worry about it. But if let's say the data is missing anywhere between 5 to 15% or up to 20%, then you have to go with the imputation. What you have to do is you have to impute the missing values with some sort of mean or median values. So in this case, we are dealing with the income. So probably the better way to replace the missing value should be median. So you can just calculate the median of the existing 710 records and replace all those 37 records with that median value that you found out here, or the mean value. But median is more appropriate in this case here. But we don't have that many missing values, so we'll just go ahead and ignore that, because while performing any kind of ANOVA or MANOVA, we or SPSS does the complete case analysis anyway, so we're not going to worry about it. But if you see the distribution is slightly skewed to the left here. It doesn't look normal, but it's not that abnormal. That's something to pay attention to. So likewise, we'll do the missing case analysis for our categorical independent variable here. So for that, what we do is we'll go to analyze descriptive statistics and frequency here. And let's say we want to do job satisfaction here. Okay, we don't want to display the frequency table. Let's do that. Statistics, we don't want to worry about it here. Chart, we don't want to create any chart here. I just want to see the missing values, and it's gonna do some frequency table, I believe. So you see that job satisfaction does not have any missing values. So this variable is coded 0 or 1. So if you go to job satisfaction in the variable view, so 1 is very satisfied, 2 is not very satisfied, and all the data have values there. So we don't have any missing values there. That's what is being shown here. So we don't have any missing values for this categorical variable. But if you have any missing value, how would you deal with it? Well, again, if you have a number of records that missing value is less than equal to 5%, you just ignore that or delete those cases and do the complete case analysis. But if let's say that the data missing is anywhere between 5% to 15 or 20%, then usually when you say categorical variable, you could do it like a couple of ways. First, one way is replace the missing value with the mode or the most frequently occurring labels in that particular independent variable. Or what you can do is you can create a separate category for the missing values and treat that as one additional label. And often, I've seen that in data mining, you go ahead and create additional variable, which is sort of indicator variable, where you did the imputation will be denoted by 1, and where you did not do the imputation will be denoted by 0. So this kind of captures the missing information of that category that you are creating additional or not considering at all. So the whole idea is if we want to make sure that the people who are not responding are not that different from the people who have responded, because otherwise if there is a pattern, then our whole analysis will be very biased. So keep that in mind. With that, you should do the similar analysis for the degree as well. So let's go ahead and do that. Statistics frequency here, degree here. I'm going to take out we could have done both at the same time. Let's do that. So say okay here. So see, we already have done the job satisfaction. We got the same table. Then we have the degrees table here. It tells you how many labels are there. We are considering these 5 labels: less than, high school, junior, college, bachelor's, and graduate. Okay, and tells you how many values are there in each category and what percent are missing. Again, okay. So I was expecting it to give me the missing values for it as well. Let's do it again. Frequency here. I'm gonna remove this one. Let's do that by itself. Okay, so degree this time does not have any missing value here. I was wondering why it, oh, it did it here. I'm sorry. Side job 2 and degree here, so they don't have any missing value each. So that's how you deal with the missing values. And the next issue we need to consider before we get to the factorial ANOVA is how to deal with outliers. Now, when it comes to the outliers, we need to sort of take the global view, not each one variable at a time. And even though I'm going to discuss more in detail in the next video, but the simplest way to do that is, create a sort of, box plot across different categories for your dependent variable. So let's do that. I'm gonna do one here for my R income 2 variable and that we just created and the job satisfaction. And to do that again, we need to go to the analyze, descriptive statistics and explore. So we have R income 2, but here I want to use job side job 2 here. Okay. We're gonna choose a descriptive stats here, but plots we're gonna choose factor level together, stem and leaf chart, not the histogram this time. Okay, if you want, you can also have the histogram as well, but we don't need it right now here. So we're gonna continue here and say okay here. So it's going to tell us like how for each category how much data is there and how much is missing. So we knew from our analysis that for this variable we have 37 missing here. So here, if you go here, this is a very nice way of doing it here. It gives you all the kind of index here what we have run so far. So I'm here right now. Let's say this error tells me I'm here. I want to focus here. So we still have 37 cases missing, 14 for very satisfied and 23 for not very satisfied, and they're very low. So we're just going to ignore that. But let's see the outlier. The outlier can be best judged using the box plot. Here you can see that we do have some outliers, right? But we don't know specifically the values here. It does give you the case number. So you can go and look for one case at a time. That's often not practicable or feasible. But this stem and leaf plot gives us better information. For example, if you see this plot here, it immediately tells me that there are even 11 employees where the income is greater than or less than 0. Okay. So less than or equal to 0. So there are 11 extreme values here. Okay, and here it tells me that for the people who are not very satisfied, there are 22 employees where they are mentioning anything less than 3 as their income level. So these are outliers, and they are not that big in a number. So we have a lot of cases here, almost we have around 700 cases. So we're not going to worry about this 11 case here where people are like mentioning, less than equal to 0 or less than equal to 3. So what we're going to do here is we're going to just ignore or eliminate these values by treating these as what we call missing values. So I will do that here. I will go to transform again, recoding to different values here. I'm gonna take my R income 2 and do it R income 3. And I'm gonna do here is this time we have to deal with the lowest. So I'm gonna take out this one here, my older one here. I'm gonna save so lowest through 3 treat that as a missing value. So anything where the employees have mentioned their income level as less than equal to 3, that will be treated as a missing value. The rest of the values will be copied as is. Okay, so we're gonna continue here. We're gonna say okay here. So that's been done here. So let's go ahead and look for that variable here. Okay, that's our income 3 here. So again, if you see this with the our income 1, let's sort this ascending. So wherever you have 0, now we have a missing value, and that's going to be up to all the 3s, right? Here, right? And then you have 4 here, and anything above 2 or 21 should be treated as missing value as well. So here, see 22 and onwards are all treated as a missing value in my R income 3. So before I conclude this video, I want to explain something else here as well. So degree, if you see degree here, degree has in fact 4, 0, 1, 2, 3, 4, 7, 8, 9 labels. So we are not this 7, 8, or 9. They are not applicable, and they should not be treated as a category here. So we need to treat them as missing values. So we only gonna worry about these 5 labels here. And if you see here, 7, 8, and 9 are already being treated as missing values, and I don't see any 7, 8, or 9 in my here. If you sort it by ascending, we have the minimum category as 0. You sort it descending, the minimum we have 4, and we already saw that we don't have any missing values, so we're not going to worry about those additional labels here. So this is how you perform the outlier analysis. Now you should be doing the similar thing with the R income 3 and degree as a independent variable, and create different box plots. So I can quickly show you that again. So how we can do that here, I'll go to the descriptive statistics, explore here. I'll just take this one out and put my degree in there. Descriptive stats, plots, we want box plots, temp plot. Say okay here. So it's gonna again give you the detail for every label in the degree, how many data is there, how many are not there. They are very uneven. It's always good to have even split, but here it's highly uneven split here. It's gonna get more uneven when we're gonna create 10 different groups, 5 here and 2 for our job satisfaction. But it gives you the missing values, they're very low, so we're gonna ignore that. We're just gonna do the complete case analysis, and it tells you the extreme values here. We have pretty much taken care of all these extreme values, so we're not gonna do that again here. Okay, so in fact, ANOVA is very robust, so we don't need to worry about these outliers as such. Otherwise, we'll just keep reducing our data set to very low. So I'm going to just ignore that. But this is just to let you know that this is how you should be looking at outliers. So with that, I conclude my video here. Thank you very much for listening.